Start with Rainer since you're like right in my vision where I'm looking.
Sure. So I'm Rainer Sigwald. I'm a developer. I work at Microsoft on developer tools, mostly MS Build. I've been at Microsoft about 12 years and I've seen a lot of code patterns, so hopefully have some useful opinions on that kind of thing.
And I'm Joel. I've been doing this for 8 or 9 years, I guess, and I software development that is. And while I don't write C sharp now, I do consider Link to be the gateway drug to all of my functional programming experience and background. And so I definitely think it's a good tool, and I especially like using functional programming not in a functional language. So really adapting its benefits to what you're doing at the time.
Nice. That's like the perfect amount of input that could be given. Someone who's worked for Microsoft, someone who does functional programming, that's like going to work perfectly. And I'm a C sharp guy, so the three of us together, maybe we can give a lot of really good input. And this isn't perfect. Nothing I do is perfect, so any feedback you guys have can improve my stuff too. All right, so let me go ahead and share my screen. And anyone in the chat, of course, it says there's 11 last time I looked. Feel free to just jump in anytime and be like, hey, why did you do this? What is this going to help? Or whatever the questions that you guys have. And Kimberly, hopefully, if you can tell me, because I'll be sharing my screen. I won't be able to see those questions. So I will say share window, share. Okay. Hopefully that's visible. I've zoomed in way more than I'm used to. I'm used to something like that. So yeah. Okay, so what I'm going to be going through here is the quintessential order microservice. It's what I use for like all my examples because order processing has a lot of moving pieces to it. I'm going to start off with what I call like the typical code. So whenever I go into code, this is something that I'll see when I'm doing a code review or whatever the case is. Start with sort of a baby version of design by contract at the top, where you've got a lot of things you want to check to make sure that this method is even being called correctly. So if the order is null, we don't want to create the order. For example, things like that. And I'm just going to walk through the things I see here. This isn't what I'm saying to do. This is what I'm saying. This is where we're going to start. And then we're going to take this code and separate the procedural portions from the functional portions. So we got that part, and then we've got this. We're getting the items from an item SDK. So it's an external system where it stores all the items. We know that we want that the order has items 1, 2, and 3 or whatever, but we don't want to trust whenever the front end sends us, oh, hey, it's $20, because who knows what they can do. So we go hit the item microservice, and we say we want to make sure we get these items. We pull them back. We make sure that from the item IDs that they sent us, that we can get them all from the item microservice, because if some of them are expired or whatever the case is, or they give us a number that's not in there, we're not going to want to continue. So this is saying, assuming there aren't any missing items, let's go ahead and do this part. So this is nesting. This is conditional nesting. You've got a condition, and then you've got a nested portion in here. And then the order items, this is very similar to the item that comes from the item SDK. But what I'm going to do is I'm going to convert it from the item SDK into an order item. So while the items microservice controls what an item is, you're sort of duplicating that into an order item. And the way that the reason you duplicate that, if you guys don't know, is because the once you place an order, you don't want, if the price ever increases, for example, in the item microservice, you don't want that to increase what it was on your invoice, because it's sort of like taking a snapshot. So you're duplicating that into your order as order items. Then we want to get the customer who's making this order, and that way we can see if that customer has discounts, their location for shipping, and all kinds of other stuff like that. And here's another one of these nesting. So if the customer is not null, then we're going to go ahead and continue on and do this. Otherwise, it'll fall through down to the bottom. So now, if they have discounts, if discounts is not null, we're going to do this, and this is a for each, and then this is a for each, and we're going to do all this calculation. We're going to get all the items. Lastly, we're going to create the order, and then we're going to return the order. So that's using an entity, because repository using entities, whereas we're stuck in models right here. So we're sending it over. We're sending it over as an entity, and then as it comes back as an entity, we're going to return it as a model. This isn't. I'm not saying this is how you do an order completely. You guys can do it a million ways, but this is very common the way that I see this code. I'll stop right here for a second to see if you guys are like, oh, hey, that's not common, or I also agree with that, or if you guys have any input, or no, if you don't have any input. Pretty good. Okay. All right. So first thing I'm going to do, assuming everyone agrees this looks like fairly common code, I'm going to say the first thing that I always say is dependency injection. Always talking about dependency injection. This is a bad thing, but that's not the first thing I want to touch on right here. Even though that's the first thing it's very important. I'll touch on that second. What I want to do is take this nesting, and switch it into guard clauses. So what we're going to do essentially is take all the stuff inside here and get rid of it. So it was doing this, else it was returning null. So now we're instead going to flip the Boolean here and say return null. And then if it doesn't do that, it's going to have all this. So first of all, we've gotten rid of some nesting. And second of all, this may seem pedantic for right now, but this guard clause is an important way of looking at code. The difference being a conditional transformation is something that you want to unit test. This is conditional, but it's not a transformation. It's a conditional, get the heck out of here, we're done, we don't want to do anything else. So this is called a guard clause. It's just going to say stop our processing. We're going to cut out here. So we're going to go ahead and do the same thing for this. We're going to cut this out and say if it equals null, return null. And then otherwise, if it happens to get past this guard clause, then let's go ahead and continue this. And now we don't even need this last one because we've covered all those scenarios by guard clauses. We've gotten rid of a lot of nesting, and now we're covering this all these scenarios with guard clauses. Let me make this. I like to usually pair guard clauses in pairs with like, this is a thing that I did. Now let's check the result of that and then maybe cut out if we need to cut out. Do you guys have any take on guard clauses, or is it the first time you ever heard guard clause before? I don't know.
I always heard it called defensive programming, so that makes sense to call it a guard clause because you're trying to be more defensive when you get to your business logic to protect it. So, yeah.
I like that. Defensive programming is another way I've heard it called too. Okay, so we were able to do that with these because these weren't controlling transformation. They were just controlling whether or not we continue with the program. This, on the other hand, is controlling transformation. If they have discounts, then we're going to transform this order by doing whatever else logic. I'll also point out that not only is this a conditional transformation, but a for each loop is also a conditional transformation. It's not an if statement, but it is conditional on like whether or not there's anything in here and what's in here. It might loop one time, it might loop different, especially a for loop where you have an iterator like I or whatever the case is. Those are conditions. I mean, you see in the for loop, there's for the value, whatever's in the collection, and then you have your iteration change I++ or whatever. So those are conditions. So for loops are conditions also. Okay, so we've done that. We've changed all of our nesting to guard clauses. And then the next thing we're going to do is pull these to be dependency injected. So I'm just going to change it to, I've already done a lot of this programming, obviously. I'm not programming completely live here. So up here we have the three that are being injected into the constructor. And in the constructor, and then all we do is we're just assigning them up to these private read-only fields. So here's our dependency injection. If you see the new keyword, other than in value objects like strings or date times or whatever the case is like that, if you're newing up services, SDKs, repositories, things like that, that's a code smell that something's wrong and just means do dependency injection, essentially. So we're going to say item SDK here, and then I'll just put new space for a search, and you can find where these code smells are. So order repo. So now we can say, we know by looking at this code that this class has a dependency on external services, two SDKs, and then the repository that's directly related to this service. So this service has a directly related repository. So we've done a good job. We've gotten rid of the nesting. We've done the dependency injection. And we can see here, just loosely defining the way that I define things, very procedural code. Do this. There's no like logic really going on here. Do this. This isn't really logic. Like I said, it's a guard clause. It's not a conditional transformation. It's just a guard clause. So just do this. It's just do this. There's a lot of just do this. It's very procedural. If you just saw up to this point, you'd be like, what's the point of functional programming? There's nothing in here. It's not doing anything. It's just hitting a database. But now you have some conditional transformation, and you've got some loops, and you've got a lot of things that are happening in here. I hope I don't get your hopes up too much, Joel. We're not going to go into a lot of really functional programming. I should have called it separating the logical parts out of the procedural part, but you'll be happy to see there is some sort of functional-esque stuff going on. And then once again, back to just some sort of procedural stuff. Before I continue on, I'm going to separate these out. Right now, for all of the same exact reasons, we're just returning null. That's you. They don't know what happened. They don't know if it's because order was null or they accidentally gave us an ID or whatever the case is. They don't know when they get back null. They don't know how far it got in the code. Look how many times we return null. This is disgusting. Null is just disgusting in general. So I'm just going to say if this equals this, then return null, et cetera, et cetera, et cetera, for all of these different things. And now I'm going to skip ahead and say, look what I've done. What have I done? Hold on. Boop, boop. Okay, so now this looks exactly the same. It's guarded. And I've split these out into the different things. Also, I'm now using what's called a monad, in this case a maybe monad, because instead of returning null, I'm going to return, don't hate me for saying this, Joel, but C# developers get this, especially from SOAP developers. It's a response object, essentially. I'm returning a thing that says, I'm not going to give you null, I'm going to give you a thing that may or may not have a value. In a monad, it's like a collection that has 0 or 1 results, but I don't want to get too pedantic here. This is saying I don't have a value, and just in case the logging is going to be done upstream, downstream, whoever's calling this by the consumer, we can go ahead and give them this. No logic should ever be based on like exception messages or result messages or anything like that. But just in case someone's debugging or whatever and they're consuming this, they can see why they got back no result, a none result. So maybe .none, maybe .none. The main thing I've changed between the last example and this is I'm now doing a maybe instead of returning null. So it looks exactly the same as before. I want to maybe even get Joel or anyone else, if you have any questions about this immediately or any feedback on the maybe in C#.
I know Kimberly raised her hand earlier, so I was just going to call that out. Did you have anything you wanted to add, Kimberly?
Yeah, I was waiting until I could find a better time. This is not related to the maybe, but earlier Alex was asking about dependency injection. Who is doing the newing?
Very simply put, it's the startup project, and it's usually a thing called the composition root. So in the startup project, you have, I mean, in ASP.NET, you have the all the startup services, startup.cs, and you have the iService collection, and it allows you to say, if someone asks for an iOrder repo, then give them a new order repo. You can do that. Or you can do some sort of auto assignment where you just say, register iOrder repo. It'll magically sweep your code and say, we found something that implements that, and so we'll use that. That's disgusting, but I don't want to get into that right now. I'm very explicit with my dependency injection. But it's the startup project. So you can imagine that this class and this whole system, I guess, in general, is in a NuGet package, and it does not know that it's going to get an order repo. It knows it'll get an I order repo, but it doesn't know it's going to get an order repo. And that way, whoever's running this or debugging this from the startup class, the API or the console or the UI or whatever it is, can say, I'm going to give you either an order repo or a test order repo or perhaps a FedEx order repo or like some other implementation. Usually it is one-to-one, but it's enough times that it's not, like 10% of the time that it's not, especially in unit testing, that you do want to interface out a lot of your stuff. I'm not saying interface everything. There's conditionals for everything, but so yeah, that's the answer, is that the composition root in the startup project, API, console app, UI, whatever, is the person who's going to do the dependency injection. They're going to new up the things. So yeah, perfect question. All right, move on. Joel, did you have anything, or do you want to move on?
I was going to say one quick thing about maybes. And so a lot of times in functional programming, people say all these things like functors and monads, and it gets very abstract and hard to understand. Really, all this is saying is that it's unsafe. And so you're pushing, instead of having your exceptions just be thrown and caught randomly throughout your code, you're saying exceptions are not part of my code flow anymore. I want this object to control my code flow. So I'm either going to get the order model or I'm going to get none, right? And so that's what is really useful for this pattern, is it puts it in the actual code flow. So whatever calling function, whatever calls create order guarded, has to actually take into account. They can't just catch on some random exception and say, oh, sure, it'll be fine. They have to say this could either be an order model or nothing, right? And so it forces you to handle all of the possible code paths in your code with the type system, with your compiler, without having to rely on your like exceptions and whatever you name them.
Yeah, that's really cool. And let me do this.
We do have another question about.
Oh yeah, do that.
Is there maybe a class with a result message, a result code?
Maybe you should think about this conceptually instead of me just showing my implementation of what a maybe is. You can imagine that inside the maybe class, it has an IEnumerable or a list or something like that. And the list will either have an order model in it or it won't. So it'll either have 0 things in it or 1. It'll never have like 30 order models or anything like that. So then the thing that gets this back will either be able to say that the collection inside the maybe has something or doesn't have something. If it doesn't have something, then I know that things didn't work out. In this case, we happen to be nicely providing a message of why. It's not necessarily what it always is inside of a monad. But if it has one thing in it, that means it did work out. And that's way better than null. Null throwing a null exception or whatever the case is, because null might be a valid, this is the main thing, null might be a valid value. For example, middle name. Let's say someone's middle name returns null. That could be valid. Or maybe it was because the database exploded, couldn't connect to it, or the SDK is down, or whatever the case is. So where null could, if we return that list inside this maybe with one value in it, and that value is null, that doesn't mean it didn't work. That means we successfully got a value, and the value is null. Instead of using null to control your code flow, you reduce it to just being another possible value inside C# that doesn't really bear any significance to your code. Just maybe something just doesn't have a value, but it successfully doesn't have a value. That's pretty much the main take on it. And I can do a whole nother thing on maybe in monads. What, Rainer?
Yeah, so maybe we should reserve that, but I wanted to ask about nullables and the new nullable analysis, which kind of promotes some of that into the type system directly and gives you some of those benefits without the maybe.
I've been back and forth on whether or not I should just stop using monads because of the new nullable system, because the way that you coalesce everything, or you say it's acceptable for this to be null, and all the stuff in the new null system is really cool. And I've tried using it, I just haven't fully committed to that yet. One of the things being that like you can't pass back a value, or you can't do the monadic way of saying if it has a value, follow this code path. If it doesn't have a value, follow this code path. Without purposely putting in if-then statements instead of using like link or that type of dot-based notation, dot-based notation development. So I've gone back and forth. Have you done code where you've replaced, you stopped using monads and you started using like the null system?
Mostly, I skipped the maybe step. In my code base that I spend most of my time with at work, they use just a lot of kind of null unsafe code and didn't have that. And as we are going in and sprucing things up, now that we have nullable, we mostly aren't introducing any type of maybe or that type of class. We try to just wrap in nullable analysis to ensure that we get that. That's hard in a larger system where it's nice if you can flip the switch on from the beginning and design your whole system that way, which is kind of the case with a maybe too. Is it's great if you have a maybe in one place, but then you have to propagate it out to all the places that you call it to.
Yeah, I compare it to the async. The moment you put one in your code, it's kind of spread.
Yeah.
I'd love to do a whole talk on the maybe thing. I think another benefit compared to just using the new null system is you can pass a maybe monad over the API. So instead of just like someone receiving an order model, they can receive the whole entire monad and see whether or not it was successful and get all the other stuff. That's why I sort of compare it to a response, like a request and response object in SOAP, which I cringe just sort of saying that because there's so much more to a monad, but it could be something like that. Okay, good feedback. So I'm going to take the next step now. We've sort of broken this down to be much more procedural and also be much more informational. And we've got dependency injection. The code's already a lot better, but we still have these things that are hitting external systems, this SDK going out to some API. We've got this order repo going directly to our database, mixed in with our functional code, which makes this a nightmare to unit test. And so if we wanted to unit test this, we'd have to instantiate our class, create mock classes of these interfaces and pass them in, and then test this whole entire flow. That more to me sounds like an integration test. We're testing an integration test, granted, where you're mocking out the integration portion, but there's just so much to it. What if I just wanted to test this right here, or the way this all works together, or I don't know, some subset? This really is its own test that I should just be able to test all by itself, and it doesn't have any dependencies in this. So if I could just say, I don't want to test any of this, I just want to test this, and I don't want to use that old Microsoft thing, was it shims and stuff like that? I never even mess with that, but I don't want to say shim out all this and just test this. So what I want to do is I want to separate the procedural from the functional. And so what I want to do is essentially say, let me just jump right over to the code and then I'll explain it instead. So essentially I'm going to say, here's all this stuff that's just happening procedurally. I actually put the DBC, the design by contract stuff, into its own thing, but we don't have to go into that too much in depth. So we've got the design by contract stuff. This is just procedural with a guard clause. Procedural with a guard clause. This is just an assignment, which there's no logical, there's no logic. It's not a logical transformation. It's a transformation of this. It's not a conditional transformation. So this unit testing this would be worthless, is the best way I could put it. The unit test would look identical to the code. And whenever you come to that type of scenario, your unit tests are just a thing that are hindering stuff from working. So that every time someone wants to change this, they got to go change the unit test. That's not the way code should work. So this is a procedural thing with a guard clause. This is some procedural stuff. This is where the logic is. So we come in here, we've got this logical stuff. We've got, this is logical stuff because it's a for each, logical stuff for each. So now we have this, I don't know how that happened. We've got this public static method. The cool thing about it being public static is that this could not possibly be using these. Since it's static, it would require a reference to the object that it's inside in order to use these. And so being that it's static, that it's not using any of the dependencies. It doesn't mean that someone isn't using a static method and newing up some sort of thing, which would be a huge code smell, a horrible thing to do, to be newing up like a repository inside here, because you cannot mock that out inside of a static method. You could, if you needed to, pass in an interface via the parameters, but that's starting to get a little bit negative also, because maybe you want to pass functions into the parameters, but you don't really want to pass entire dependencies, because then you have to mock out entire dependencies where you should really only be using like maybe portions of those dependencies. So the simple part, once you've gotten everything down, you've gotten rid of all the nesting, you've done your dependency injection, you can really find these parts that are actual conditional transformations, because this wasn't a conditional transformation, it's just a guard clause. This wasn't a conditional transformation. You've broken it down as far as you can. You said, okay, these parts are not guard clauseable, they're conditional transformations. And now we have this. And now if you want, you can unit test your actual logic. And I wish I could do, I thought I had something in here that was actually passing in funcs so that I could have Joel have something to poke at. Let me show you guys an example of that, because sometimes you do need some sort of function or some sort of logic somewhere. So I'm going to say I need some code here that says if true, you can imagine there's something right there. If true, then then do this. Actually, let's say this. And we're going to say this is a maybe of order entity, so maybe of order entity. Okay, so now we have some sort of conditional transformation. And so what I'm going to do is I'm going to move this into something called conditional transformation. And I'm going to say I know this isn't quite right. Let me see. Maybe dot none. I'm not going to do a full implementation here, but I'm going to do something very basic here. So this means it couldn't do something. This one I'm going to say return. Okay, so we've got our condition, and we've got this thing here. This is only underlined because this is purely true. But it's assuming this condition could possibly be false. This is not going to work because it's static, and we've got this dependency right here. But we want to be able to unit test this. So what we're going to do instead is say, I know that this is a function that takes in an order entity. It takes in an order entity, and it returns a task of maybe of order entity. So what I'm going to do here is I'm going to say func that takes in an order entity and returns a task of maybe of order entity. I'm going to call it, and just call it create order. All right, so we've got this function called create order. Make sure I'm crazy. I'm a crazy person. All right, so now we no longer have a dependency in here on that. And now here inside of our procedural code, where we have access to all those dependencies, the database and everything like that, we can put, I'll just go ahead and pass it in like that for now. So we can put this information. So order repo.create is the name of the method. That method matches this exact signature. So we can go ahead and just pass that in. Or if we want, we can actually do this. Async x into await and my microphone's in the way of me seeing things. Okay, so this is just saying with this lambda where we have an async x because it returns a task, we're going to await create whatever that order entity is. So here we're passing in that order entity, which becomes the x, which then passes it into this. So what that allows us to do is say, if we were going to unit test this, then we, instead of mocking out the entire repository, possibly any logging that's happening in the repository or anything crazy going on, we can just mock out this one function inside of our unit test and pass it directly into this method. And then in this method, as far as it's concerned, is pure because it's calling create order. It doesn't know if that's hitting a database. It doesn't know if it's hitting an SDK. It's just saying this is probably just another functional method. As far as we're concerned, who knows what it's doing? I trust it. It's pure. And I'm doing everything pure and functional as far as this code is concerned. So that's a way that you'd be able to, if you feel like I can't pull this code, it was really easy here. It's really easy to pull this into another method because it didn't have any like deeply nested calls that required a dependency. But if it did, I would just take the method signature of that, pass it in as a parameter, just like I did here. I took the method signature of what I needed and passed it as a parameter. And now I don't have to mock out entire services or go through this whole entire method. I can just mock out that one little call and send back whatever I want. So yeah, how much have I blown past questions or anything here?
Just got one. Does func replicate a method signature from the repo?
Say that again?
Does func replicate a method signature from the repo?
Yeah, so func can be exactly whatever you wanted. And really, a really cool thing here, I don't want to get too in depth, is that the func doesn't have to be exactly what was in the repo. So if I did the order entity up here, so I've converted my model, my order model, into an order entity up here. And then up here, I just wanted to do the logical part. I didn't want to do the conversion here. So I'm not passing in an order model. I'm going to pass in an order. Actually, I'm not even going to pass in anything. So here, I'm just going to call create order and say action. I don't require anything back. I don't even know if I'm doing this right, but I'm going to find out. Action, it's a task. That'd be a func returning a task. Func returning a task. Okay, so this obviously does not match the repository method. I'm just saying create order, or await create order, and I don't need to return anything. Let's just say, I don't even know what I'm doing anymore. I'm just trying to make a sample here. And good enough for now. Okay, so the cool thing is I've still pulled the logic part into this static method so it can still be unit tested. This obviously does not match the repository pattern. But since I've already converted this up here, I can say bam, and I'm not expecting anything here. So maybe async this, create this. There's a little bit extra going on here. But so instead of passing in instead of duplicating the repository method here, since I happen to already have the entity up here, I could very well use that here. So I'm calling, this function is perfectly fine to call into here, but it doesn't have to match. This can be the repository method. I already have access to some of these parameters. You might call this like currying or partial or something like that, where this only needs to know that I need to call a method, or maybe with one or two parameters. This has access to all the parameters, something like that. So it doesn't directly have to duplicate it. It just has to use the portions that you need during this functional portion. That's logical. And func is one way to do it. That just means, in case not everyone knows, a func expects a delegate that returns task, or input, and then return type. So like this would be string, integer, model, or whatever. Whereas an action is just like a void method. It has 3 inputs, but there's no return type for an action. For anything that you're doing asynchronous, though, even if there are no return types, it's usually going to be at least a func with task, because it has a return type of task, but task is essentially a void inside the asynchronous world. So yeah, it doesn't have to directly match. You can do a little bit of I'll call it currying for lack of a better word right now, where this only has access to whatever method parameters, and this has more access to more parameters, something like that. And it's actually a fairly common pattern for something like currying if you want to do something similar in C#. So I'd love criticism and feedback from you guys, but also agreement is cool too, but criticism and feedback's really good.
I like what you did. I was just going to say, I think this is where people say, like, oh, pure functions are good, and they turn it up to 11. And now you almost like work your way away from the transparency of your code. And so now you have this create order function that you're applying inside another function. But it's like you have to like go to definition several times to actually see what the create order does. And so now you've made yourself a little bit easier on the testing front. But you've actually made your code slightly more obfuscated as far as like actually understanding what each line does. So that's where I usually, like, I work at startups where we never have time to go back and do this. We have more business logic that needs to be written, so we never quite get this far. But that's just my thought.
Yeah, that's something similar to what I was thinking. Is one of the things that you did is you pulled a database access into a static function by passing in a method that does a database access behind the scenes. And that kind of transformation, it's not always wrong, it's not always right, but it can make some of your performance characteristics interesting, because you're like, oh, I'm just calling this lambda that was passed in, and it's the caller's problem if they, block for 5 seconds waiting on a database result, but that may manifest as your actual code appears to be hanging in a weird place or having interesting performance characteristics because of that level of abstraction. And sometimes if you can pull, if you're passing data into your pure functions, your static functions, that is often better if you can do it.
Yes.
But
yeah.
Like there's trade-offs on all sides of that, of course.
Yeah, which is why I wasn't doing it. Ooh, here's my feedback. Which is why I wasn't doing it at first with this one. I'd rather go back with this. If you want to see that, of course, it's in the video, so you can always go back to that stuff. So here's the conditional part. So I wasn't doing it with this method because we could do the data part here and then possibly pass that into something else. Just like these, where we're doing the part where we get the data, and then we can pass these items eventually, or the customer, we get the data from the customer, we pass that in here. If you start getting too far down the rabbit hole where you have, like Joel was saying, functions passed into functions, passed into functions, passed into functions, then you have to trace back up the references and find who all is using this, what all they're passing into it. It starts to get a little bit confusing. But also, like you guys said, I would say prefer to do that at least to one level of abstraction. If you start getting 3 or 4 down, maybe it's a code smell. Even 2 down is a code smell. But there are 2 benefits. One is the unit testing. So you can separate your unit testing from your integration testing, which then makes deployments and continuous integration. I mean, there's all kinds of benefits on that side. Code readability or traceability is a little bit harder because you'll see it takes 5 minutes to run this thing, which is part of a link function, which is part of this method, and you got this stack trace, and then it's really hard to find where it came from. I don't try to code for traceability directly, but it is definitely a big consideration. I'm 30% of my consideration, something like that. But another thing it does other than testing is it gets you to some really clean procedural programming. So you're saying, I'm making sure that your order is good, I'm getting the items, I'm getting the customer, I'm doing all the functional stuff, I'm creating the order. This tells a very clean story looking at this procedural programming versus the original thing, which it's readable. You can go through this just like most code. Yeah, it's readable. But when you start getting into is this even the original one? Oh, because I've already cleaned it up. Gosh dang it. But yeah, it had like the nesting inside of it. It wasn't doing dependency injection. There's a whole lot of cleanup that you can do. So there are the pros and cons, and just like anything else, weigh those, especially if you're going 2, 3, or 4 deep, passing in these funcs to funcs. Then that starts getting a little bit messy. So 100% agreement with you guys on those. Definitely something that people need to keep in mind. Still, at some level, you want to try to separate your procedural stuff from your functional stuff. This is my talk, so this is what I'm saying as my as my input to help you separate your integration testing, your dev integration testing, your full system testing from your unit testing. So right now, I'll point this part out. I am using partial class. There's a lot of other patterns you can do to do this, but I do this where I have the same exact named class because they're all part of the same thing. But inside this logic folder is where I've got these static methods. These are disgusting, I know. You can't test this, but yeah, these are all static unit testable portions of the code. It's where all your algorithms are going to be. You'll see some funcs passed into here, here and there, but this is usually this class, which I call the implementation class because it implements the interface. This is the procedural portion. It tells the story about what's happening, but it doesn't get into the nitty gritty about the functional algorithms and things like that. So, yeah. Any final input?
Yeah, we did
Go
have
ahead.
a couple things. I think we lost the context on one. I was distracted by the other one. But Alex said he saw order being passed in, but not where it was being used in conditional transformation. That's been a couple
For that
screens.
method that I created down here. Yeah, so the order was being passed. No, I took out where the order was being passed in. Whenever I decided, let's go ahead and pull this out. Entity equals this, whatever. So I pulled it out from being passed into that other method and said, so this would be entity. And so instead I was calling that other method. I might have accidentally been passing it in here, but I took it out of the signature of the other one. So I'd be async, bam, bam, and then this. So in the other method, in the other method, you would have all the conditional portion of it, and then it would just call into the func that it has, and it just calls the func with an empty parameter because it doesn't have the model or the entity. It doesn't have that at the time inside that method anymore. It was just doing whatever it was with the conditions. So you might be passing some sort of booleans or other things in here for whatever your conditional statement is. Not in here, in here. You'd be passing some true string thing, whatever. And these would what you'd be using for your conditional transformation, your conditional logic. But then once your conditional logic in that other method went through and said, okay, do the action that updates the database, whatever you want to call it, create object, it just calls an empty function, an empty asynchronous function, which comes to here, and this can call that create using the entity that it already has access to. So the entity doesn't have to be passed in and then passed back into here with an X, and then this using an X, because then it's just only being passed around for the sake of being passed around, whereas we have access to it here already. I know it's a little bit abstract because we've gotten rid of all that stuff, but hopefully that sort of answers the question. I think I was still passing it in on accident up here, but I had taken it out of the parameter list in the method that I created.
Yeah, hopefully that answers Alex's question. I think he's planning to get on the call after we end the stream. So just want to mention again that y'all will all be invited to join us here to ask more questions after we're done.
Did have one minor thing, if I could point it out, and it's not really a problem. It's more just like how I would approach it a little differently. On your assign discounts function, I'll try to talk loud. I know Twitch is making me quiet, but you pass by reference, and so you mutate the order within your assign discounts function, and that's definitely going to be like more optimal for memory management. But I'd say that might be a premature optimization, just because we don't necessarily know that assign discounts is like a memory hog. You could be saving like a handful of bits and like maybe making a bug easier to code when someone touches this, several months from now. And so that's why I usually just never mutate in a peer function, always just return an object that isn't a new constructed object.
Yeah, I agree. I think it might have come up because I did control RM and it automatically did a ref on there or something like that. So I'm going to say I completely agree with that. And this is definitely a type of pattern that I would say that people should be following. I'm not saying this is exactly where the return would be, but it should be something like that for sure.
the new C# records and with clauses also make that kind of operation easier.
Yeah, yeah. I do love those. And those are really, really good, if people don't know, for whenever you're passing objects into to some other thing and you don't want it mutated, and you like do order with something like this or something like that, then you'll pass in pretty much a copy of the order, and then your order won't get mutated for sure. And then you could even, this would even still work because it'll assign the new order that has been transmuted. I don't know, there's a lot of other patterns with that, which are really cool. I think I'm set up. So if you guys don't know, record is a new type instead of class, and then this would work. So now it'll be creating a new thing. Yeah, actually, I shouldn't be doing any talk on records right now, but order rec equals, yeah. This is going to be an exact copy of this order, and that only works because it's a record, and this is pretty much a struct. If this was like a service, you wouldn't want to do that. This is essentially a struct, and so it'll be able to copy all the objects, all their values over, and instead of having to create your own clone method and all that sort of stuff, which is really cool. Yeah, other questions?
Yeah, Michael was asking, is that a deep copy?
No, it's not a deep copy, because if they're objects, then it's not going to be able to copy them over by ref deep. It'll copy over all of the ends and strings and everything like that, and then the object references, it'll copy the reference over exact as it is. Correct me if I'm wrong, Rainer, but I'm pretty sure that's how that works.
Yeah, a record is a struct, so the compiler transforms it into a struct and writes a bunch of the methods that you would have to copy paste to do all the individual fields creation and things like that. So it's not particularly different from a struct, especially with deep copying. It's copying the fields of the struct that it creates, and it's not looking inside them.
Yeah, so since this is an integer, and it copies an integer to an integer, those are going to be two different things on the stack. And this is an integer. But this is going to copy over this exact list to the list of the other object, and it's going to be the same exact items, even by reference. So each order item in this list is going to be the same object on the heap as it is in the other one. But then again, if you remove an item from this instance, whatever this instance is, your other instance, it will not remove an item. Yet the items that are currently in the list that were already shared from the beginning, those would be the same exact reference. Now, if you want to, I played with this a little bit. There's a static order model. I'm pretty sure this is it, or something close to this. There's a constructor that they have that you can override that overrides the way that with works, and so it'll pass you in the order with the with items and stuff like that, and you can make it a deep copy. I went along that path a little bit just to see if I could, and it was messy to say the least. I wouldn't really suggest doing that, but if you like to have fun, that's something you can go ahead and look at. And I like the way that this goes because we don't have to necessarily talk about the dependency injection or the things I was talking about here. Anything that spins off from this is good. We're pretty much done with the time. But if you also have spin-off questions to join the chat after this, jump in the chat room, then that's perfectly fine too. I think that's it. I don't see Kimberly saying that there's anything else in Twitch chat. So you want to close us out?
Yeah, just want to say thank you to Fletch for doing this talk, and for Joel and Rainer joining us, and again to Fletch for stepping up to take over as the main leader of the group, and also being the very last minute Twitch streamer today. So I know that was kind of a lot for him to do, the discussion and the streaming, but hopefully that worked out okay, and we will see y'all. Yeah, people are saying the volume was a little bit low, so we'll look into that for next time. But yeah, thanks for everyone who joined the chat and asked your questions and made comments, and feel free to continue that. Here in a second, I'll post a link to this call, so hope you all can jump on and chat with us for a little while before you have to get back to work. And we'll see y'all in Slack, and then on October 4th for our next meetup.
All right, guys. See ya.